All right, so let's go ahead and complete the square. Who got an answer for number one? So number one kind of goes back to what we talked about yesterday. This is the recipe. So we're going to follow this recipe to a T. This is what we're going to do, these same 6 steps. Okay, so the first thing we're going to do when it's completing the square, you don't want it to equal 0. It's the only method that should not equal 0. So instead of subtracting 10, we're actually going to add 13. So let's go ahead and add 13. And I'm going to change it to X instead of V. So if you kept it V, that's okay, but I'm just going to make it X. So that gives you X squared minus 14X equals 23. It's a little bit of a lag. Sorry, y'all. Okay, step number 2 is factor out A. Now, in this particular question, A is 1. That's the number in front of X squared. So we can actually skip that step in our recipe. Now let's go to step 3, which is adding B over 2 squared to both sides. So I'm going to add, this is my B. I'm going to add negative 14 over 2 squared to both sides. What do you get when you take negative 14 divided by 2 squared? 49. So I'm going to add 49 here and here. All right, so now we're ready to factor this down. And this should always factor down to a perfect square. So I need 2 numbers that would multiply to be 49, but adds to negative 7. And that is X minus 7 times X minus 7. So we're going to add the 23 plus 49, and that would be 72. So now we're going to eliminate that square by taking the square root. And the square root of 72, when we look here on this board, we need a perfect square that will divide into 72. So what perfect square, what's the largest number in this list that will divide into 72? 36, good. So this is going to break down to X minus 7 equals plus or minus the square root of 36 times 2, which is X minus 7 equals plus or minus 6 root 2. And then your very last step will be to add the 7. On Friday, you will have your first skills check. It will be open note, and it is over Appendix 6. So there will be one question where you have to complete the square, a factoring question, and a quadratic formula question. Now, question number 2 is a little different because it has that A value that we have to take into consideration. But we're going to start it off the same way. We're going to begin by adding 85. So that would be 10x squared minus 20x equals 80. Now for this example, because A is 10, I am going to divide both of these terms by 10. So both of these will be divided by 10. Do you mind bringing me my water cup since you're up? Thank you so much. I appreciate it. Pretty thirsty. Thank you. So I'm only going to divide both of these by 10. So when I divide this by 10, 10 goes on the outside. So I'm dividing 10x squared by 10 and negative 20x by 10. So that gives me x squared minus 2x inside of my parentheses. So now we're on step 3 of the recipe, which is adding b over 2 squared. Now when I add b over 2, this is b, so I'm going to take negative 2 divided by 2 and square it. So negative 2 divided by 2 is there's one on my desk. Oh, and there's a handout up there. I took a copy of the page at the very top. Or here, take this. That's the copy of the page, yeah, from the book.
Thank you.
You're welcome. Okay, so what's negative 2 divided by 2 squared?
1.
Positive 1, so we're going to add the 1 here. And then on the right, I'm actually going to add 10 times 1 because it has to be balanced. Because we have to remember that we really didn't add a 1. I really added 10 times 1. So that's why I'm adding 10 times 1 on this side. So take a moment and factor this down. And that should give you 10 times x minus 1 squared equals 90. We're going to divide both sides by 10. So that would be x minus 1 squared equals 9. Then we're going to take our square root. And this is the first time that we actually had a perfect square. So we have x minus 1 equals positive and negative 3 because the square root of 9 is positive 3 and negative 3. So what you'll have to do is break this apart. And you'll have x minus 1 equals positive 3 and x minus 1 equals negative 3. So go ahead and solve both of those to get your 2 answers. So whenever that happens, that just means that we could have also factored. So we get x equals 4 and we get x equals negative 2. All right, any questions about our bell work? Okay, so we're going to actually start Appendix 7. So in your notes, if you want to, so that's the end of Appendix 6. I am going to answer homework questions at the end of class. So in your notes, if you're titling, you just call it Appendix 7 Complex Numbers. And that's what we're going to start today. Appendix 7 Complex Numbers. So now we're starting the material that's for homework 2, which is due on Monday. All right, so first of all, what is a complex number? You don't necessarily need to write this down, this definition, but just know that a complex number is when you're adding a real and an imaginary number. So we're going to add, subtract, multiply, and divide. We won't get to division today though. All right, so take a minute and copy down these 4 questions and then we'll work through them together. So first we're gonna add them for question 1. For question number 2, we will subtract. For question 3 and 4, we'll multiply. And then tomorrow we'll talk about division. Right. Okay, so the first one is addition, and all we're doing is combining our like terms. So we're going to add together our real numbers, so that would be the 2 and the 7. And then we're combining our imaginary numbers, and that's all that's to it. So 2 plus 7 is 9, and negative 5i plus 3i is negative 2i. And that is your answer. That's it. So we're in appendix 7 now. We're doing something different. Adding complex numbers is just combining like terms. I think appendix 6 is probably the hardest, only because of the solving, but I think you'll find the rest is pretty easy. All right, question number 2, we have to subtract. So what I like to do is I like to distribute the negative, okay, and then combine like terms. So I have 3 plus 11i minus 8 plus 4i. And then I combine my like terms. Now you get the same answer if you don't do that though. So if you were to just say 3 minus 8 and 11 minus negative 4, you would get the same answer. So now we're ready to combine our like terms. So we have our real numbers, and then we have our imaginary numbers. Go ahead and add those together. And you should get negative 5 plus 15i. The negative over, yeah. But if you didn't, if you put 11, you could do 11 minus negative 4, which is the same thing as 11 plus 4. So either you carry over the negative and add, or you just subtract it. You get the same answer. All right, let's look at number 3. So who learned to multiply with a box? No? Okay, well, I'm going to do it with a box because I feel like that's how you learned it in algebra 1 and 2, but we'll do it 2 different ways, with the box and without the box. That's an ugly box. Let me do that box again. I can do better. Let's make a little nicer box here. And now we're going to multiply. Now you have to remember though, there's only one thing to remember when it comes to operations, and that's that I squared equals negative 1. And that's going to come into play in this box here. Only this box. Okay, so if you come across an I squared, we have to change it to negative 1. So now let's multiply our box. So we have negative 2 times 3, which is negative 6. Negative 2 times 4i is negative 8i. 3 times negative 5i is negative 15i. And then in that last square, negative 5i times positive 4i, that is actually going to be negative 20i squared. But I'm going to do this outside of the box for now. And the reason why I'm not writing it in my box is because in that square only, we have to do a little bit more work. Because we have negative 20i squared, which is really negative 20 times negative 1. So in this box, we should have a positive 20. It's a little bit of a lag is coming. And then you're going to combine your like terms. So you're going to add together your negative 6 and the positive 20. I really hope that this recording doesn't mess up because of the internet. If it does, I'm sorry, y'all. I'll still put it up. So So we'll wait a second. It should be back up soon.
Multiply them together?
No, you're gonna combine them.
Oh,
So you're adding together your like terms, just like in numbers 1 and 2. Should be coming back up soon. Guess we should plan accordingly because we know that the internet is going to go down at 11:08 and come back up sometime later. So, okay. All right, we back. Okay. So, after you do that, so we have a negative 20. So in this square, we really have negative 20 times negative 1, which is a positive 20. So we're just adding these two together. So when I add negative 6 plus 20, you get 14. And then we're going to do the same thing. We're going to add our imaginaries. And when I add those two together, you should get negative 23i. All right, go ahead and do question number 4. And I will look around and see how we did. Make your box and multiply it. You normally would write the real number first, but that's not wrong though. I would mark it wrong, but it's usually the real number and the imaginary. So it's going to be 2 times negative 1, which is going to be negative 2. Okay, let's go ahead and work through it together. That wasn't bad though. You did good. This won't be on the skills check Friday because this is appendix 7. All right, so let's go ahead and make our box. So we have 4 times negative 3, which is negative 12. 4 times 2i is 8i. Negative 3 times I is negative 3i. And in this last box, we have 2i squared. And 2i squared means 2 times negative 1. So what we really have is a -2. So when you combine your like terms, we're adding together. I always start with the real numbers first, so that would be a -14. And then we're going to add together our imaginaries, and that would be a positive 5i. Okay. Raise your hand if you had that as your answer. All right, any questions about how to do that? Okay, so the only other thing I want you to do is kind of go back to A6 a second. Take a minute and copy this down in your notes. This is your discriminant test, and then I'm going to open the floor for homework questions. So the discriminant test is really simple. It's just the quadratic formula. So if you're asked, if you see use your discriminant test on the homework or on the quiz, it's not the whole quadratic formula. This is your discriminant, what's underneath the square root. So this is the part that you would have to do. The discriminant test means you only find this. Okay, and when you do that, it will tell you how many and what kind of solutions you have. So I'm going to give you a couple minutes to copy this down, and then we'll talk about it. And then if you have any questions over homework 1, we'll do that, and then that's it. No real solutions. You could also say too imaginary. You could also say too complex. So there's a lot of ways to say too imaginary. So you could say 0 real solutions. You could say complex. So if you get a positive number, that means you have 2 real solutions. If you get a number that's negative, you have 2 imaginary solutions. Imaginary is the same as not real. And if you get 0, then you only have 1 real solution. So I'm going to show you an example. If you get a positive number, that means you have a parabola that crosses the x-axis twice. That's what that means. But if it's negative, what that tells us is that our parabola never touches the x-axis. So it's going to be higher up. So that's what too imaginary means, that it's not going to touch the x-axis at all. And if you get 0, it just touches it, but it doesn't cross through it. It looks like it's sitting on the x-axis. So that's your 3 different types of parabolas. And you can tell what that parabola is going to look like based off of your discriminant. All right, do you have any homework questions that you would like for me to go through? Yes.
Grab the paper. Not really. I didn't really put the answer to this correctly on the homework.
Okay.
Can you tell us about that?
You're right, absolutely. When did you turn it in?
Yesterday.
Okay, that's all right. Any other questions? Any questions you'd like me to work through? Okay.